Hello friends, welcome to the next lecture of this series. In this lecture, we are going to discuss about the combination of two simple harmonic motions, or we can say that the Lissajous figure. We know that when a force which is perpendicular or when a force which is proportional to the displacement is acted upon a particle, then the particle will execute a simple harmonic motion. When such type of two forces will act on that particle, then the particle will execute a motion which we can say the combination of two simple harmonic motions. And these two simple harmonic motions, we are here using the word combination of two simple harmonic motion. And each simple harmonic motion which we would expect when either force would absent. So these two forces when act on the particle will execute a different type of motion different from SHL, and this motion we can say that combination of two simple harmonic motions. Here we are going to discuss about the situation when two simple harmonic forces are acted on the particle in the perpendicular direction. Okay, so this situation we can visualize by taking this example that suppose here is a mass and the mass is connected to a rigid support by a spring of spring constant K1 and also connected to another rigid support through another spring of spring constant K2. If we displace the mass from its initial position to suppose this much final position, then both the spring will stretch with some distances, and the force, suppose this is the net displacement, the force produced or the force applied by the spring K1 on the mass M will be proportional to this much displacement, because the force produced by the spring K1 will be proportional to the displacement in the direction of orientation of that spring. Similarly, the force produced by or the force applied by the spring K2 on this mass will be proportional to this much displacement. We cannot say that the force applied by the spring K1 will be proportional to this displacement, because the force will be proportional to that much displacement which is in the direction of the orientation of the spring. So if these two forces acts on this mass simultaneously, then the mass will execute a different type of motion, and our task is to calculate the equation of motion or to derive the equation of motion when two such forces will act on that particle. Okay. Suppose first force acts on the particle, and by this force the particle executes a simple harmonic motion in the x direction, and the equation of this motion is given by x is equal to a1 sin omega t. Similarly, suppose the second force acts on the particle, and by this action of second force the particle executes a simple harmonic motion in y direction, and this motion will be given by, or this equation of motion will be given by y is equal to a2 sin omega t plus delta. Put it as equation 1 and put it as equation 2. Here we can see that these two simple harmonic motion equations have two separate amplitudes, and also there is a phase difference between the two equations. Here we are taking very general condition, After that, we will put the special cases or we will put the different values of this phase difference. But deriving the general equation, we will take the general case. So, this is the two equations of simple harmonic motion. This motion is in the x direction and this motion is in the y direction. Our task is to derive the equation of the motion that we will get when the two motions are taken simultaneously, or we are going to derive the relation between x and y. So from equation 1 we can get, from equation 1 we can get the values of sin omega t. Sin omega t will be x by a1. From this we can get the value of cos omega t also. Cos omega t will be equal to 1 minus x square by a1 square root over. So this is the value of cos omega t. Now we will expand the second equation, that is y is equal to a2 sin omega t plus delta. This is the bracket. Now we will expand the second equation. So the second equation, y will be equal to a2. Here we will put sin a plus b formula. Here sin omega t into cos delta plus cos omega t sin delta. That will be equal to y by a2. Here we will replace sin omega t by x by a1, x by a1 cos delta, plus here we will replace cos omega t by 1 minus x square by a1 square. 1 minus x square by a1 square into sin delta. Okay. Now we will take this term to the left hand side. Y by a2 minus x by a1 cos delta, that is equal to, I am making the square at a time, 1 minus x square by a1 square into sin square delta. In the next step, we will find the square of this bracket. By squaring this bracket, we will get y square by a2 square plus x square by a1 square cos square delta plus 2xy a1 a2 cos delta is equal to your sin square delta minus x square. I am writing this place, sin square delta minus x square by a1 square sin square delta. By simplifying this, we will get y square by a2 square plus x square by a1 square. If we take this term to the left side and take common the term x square by a1 square, in the bracket there will be cos square delta plus sin square delta, and the value of this will be 1. here this is minus, because this is a minus b whole square, minus 2xy by a1 a2 cos delta, that is equal to sin square delta. We can see that this equation represents an ellipse, but this ellipse is not symmetric about y-axis or symmetric about x-axis. The general equation of ellipse which we have gone through is x square by a square plus y square by b square is equal to 1. This is the general or very common equation of ellipse, but this equation is, or this ellipse equation is symmetric about y-axis and symmetric about x-axis. But due to presence of this term and this term, this ellipse is not symmetric about x-axis or symmetric about y-axis. So the shape of the figure will be decided by this term only, and which says that the shape of this figure will be the shape of an ellipse, but the orientation will be something different. Then we will draw this figure of this equation. So this will be the figure, or this will be the graph of this equation. Here we can see that the maximum value of x will be a1, because the maximum value of sin omega t is 1. So the maximum value of x will be a1 and the maximum value of y will be a2. So this distance is a1 and this distance is a2. This is the maximum value of x and this is the maximum value of y. And if we put y is equal to 0, then we will get the 2 points at which the ellipse caught the x-axis, because when y is 0 then it is x-axis. So putting y is equal to 0, when y is equal to 0, when y is equal to 0, x square by a1 square will be sin square delta, or here I am writing x square by a1 square will be equal to sin square delta, or x will be equal to plus minus a1 sin delta. Okay, so for the value y is equal to 0, the value of x will be plus minus a1 sin delta. That means this ellipse will cut the x-axis in the, or this ellipse will cut the x-axis at the point plus a1 sin delta and minus a1 sin delta. So this point is a1 sin delta and this point is minus a1 sin delta. Similarly, by putting x is equal to 0, when x is equal to 0, then y will be plus minus a2 sin delta. This means by putting x is equal to 0, we are coming to the x-axis. This means this ellipse will cut the y-axis at plus a2 sin delta and minus a2 sin delta. So this point, say plus a2 sin delta, and this point say minus a2 sin delta. So this is the expression of, or this is the explanation of the figure. And now we are going to use the different conditions or different cases. The first case will be when there is no phase difference between the two simple harmonic oscillators. That will be our first case. Case 1. Case 1. Here, case 1 is delta will be 0. Delta will be 0 means there will be no phase difference between the two motions. So let this is equation 3. So we can put delta is equal to 0 in the equation 3. By putting delta is equal to 0, the equation 3 becomes x square by a1 square plus y square by a2 square. Here cos delta is 0 means cos delta 1 minus 2xy a1 a2 is equal to 0. That will be equal to here x by a1 minus y by a2 square, that is equal to 0, or y is equal to a2 by a1 whole into x, which is the equation of a straight line. Y is equal to mx, and here the y-intercept is 0. So the equation of motion of the simple harmonic oscillator or the combined equation of motion will be the equation of a straight line. So if we draw the figure in the graph, we will get the figure will be like this. Let us inscribe the figure inside a square, and this is, let's say, x-axis and this is y-axis. The equation of motion is a straight line and with y-intercept 0. So this will be the equation. So this will be the combined equation of motion. Here is the equation of straight line. This is a straight line and y-intercept is 0 because it cuts the y-axis at 0, and the slope, this is the theta, and the slope tan theta will be equal to a2 by a1 minus a2 by a1. Okay, so this is the figure, or this is the Lissajous figure for case 1 when there will be no phase difference. Then we will discuss about the case 2. Here is case 2. This is the first Lissajous figure. Let me write here. Lissajous figure 1. Lissajous figure 1. So this is the second Lissajous figure. For case 2, we are taking delta is equal to pi. So I have erased the equation, and the final equation was x square by a1 square plus y square by a2 square minus 2xy cos delta by a1 a2, that is equal to sin square delta. Here we are putting delta or phase difference is pi. So by putting this value, we can get x by a1 square plus y by a2 square, here plus, because cos pi is minus 1, so minus minus plus, that is 2xy by a1 a2, that will be equal to 0 because sin n by is 0. Here this is the equation of a plus b whole square, that is x by a1 plus y by a2 square is equal to 0. And if we remove the square, this will be equal to just removing the square, the equation will be like this. And if we write in the form of the equation of a straight line, it will be y is equal to minus a2 by a1. So this is the equation. Okay. So y a1 into x. So here there will be no minus symbol, only a2 by a1. The slope is a2 by a1. Here we can see that there is a negative slope with y-intercept 0. So if we draw the figure, let us draw the square in which the figure is going to be inscribed. This is x-axis and this is y-axis, and the figure will be like this. And just adjusting the figure with respect to the equation. This will be the equation of path. This will be the path of motion when there is a phase difference pi. So here y-intercept we can see 0. This is x. This is y with a negative slope because the angle with x-axis is greater than 90 degrees, so the slope is negative. And the third case. Is when the phase difference between the two oscillator is pi by 2. Case 3. That is phase difference is pi by 2. If we put the value of delta, that is pi by 2, in this equation, we will get x square by a1 square plus y square by a2 square. Here cos pi by 2 is 0, that is equal to, and sin square pi by 2. Sin pi by 2 is 1, sin square pi by 2 is also 1. This is the equation, and this is the equation of ellipse which we have already gone through earlier classes. This equation of ellipse is symmetric about y-axis and also symmetric about x-axis. If we draw the figure will be like this. Suppose this is the ellipse. X, this is y, this is the semi-major axis and this is the semi-minor axis, that is A2 and this is A1. A2 is the maximum value of x and A1, this is A1, this is A2. A1 is the maximum value of x and A2 is the maximum value of y. So these are the three Lissajous figures depending upon the phase difference between the two simple harmonic motions. So these type of motion are produced by the result of combination of two motions, and we can see that the combined motion is not a simple harmonic motion. The combined motion is sometimes an ellipse, sometimes a straight line having a negative slope, and sometimes another straight line having a positive slope. So this is all about the Lissajous figure. Thank you.